If the stratosphere is a thin atmosphere, how will the vehicle move? Will propellers be just as effective, or do we need jet engines? You can use plasma engines, ion engines, or even make large propellers with a really wide span, not jet engines.
There is simply, in general, an optimal propeller pitch size and blade width, typically for different atmospheric densities at altitudes of 20 kilometers. The atmosphere is, certainly, exceptionally rarefied, but since it holds the shell due to its density, we also have the ability to push off from it. Of course, the diameter of the screws there is probably approaching 10 meters or even more. And this is a separate technological task, how to deliver them there, how to make sure that they do not damage anything there during their work. But all this is possible. Aerodynamic propellers work at this altitude.
Yes, and everything is calculated perfectly. Their efficiency is quite okay.
It's essentially just a distinctive and unique kind of propeller, just like gas turbine engines that are highly effective and efficient at 18 kilometers, but less so in their operation at 12 to 14 kilometers in performance. This is indeed the same. Meg 31. You can't create a universal vehicle. It has its own cruising altitude where it's most effective.
I believe there is no universal medicine. There is a problem, and you solve it using certain methods that are specifically suitable and effective for solving these problems. Does it make sense to climb so high? Maybe a 10-kilometer cable would be enough. Let it hang on a leash. But we just touched on the fact that 10 is already an ambitious task, 2 to 3 of which can be solved now. 10.
And then there's the issue of predictability. Everything at altitudes up to 15 to 18 kilometers often tends to create a lot of parasitic circulations, such as eddies. If you look at various wind patterns in the stratosphere, you can see that. There are significant and serious continental effects happening there. The obstacle for the wind heats up here, creating an intricate picture. From the perspective of wind predictability, you definitely need a higher altitude. Such beautiful circulations across the entire planet start at 18 to 20 kilometers.
It is still more ergonomic to launch the stratosphere on hydrogen. There is not enough oxygen there anyway, and hydrogen is not as fluid as helium and is easily replenished, or from a delusion.
Their buoyancy is roughly equal, allowing them to float equally well in the air. When it comes to practicality, hydrogen is definitely used in larger vehicles, such as airships and balloons, due to its lighter weight and greater lift capacity compared to other gases. There are specific regulations and a certain order of operations for that, especially with hydrogen, since it's a flammable gas unlike helium. It's possible. I mean, the serial production and mass use of such devices is always tied to hydrogen. It's just about economic efficiency. And really, hydrogen can be produced much more easily. Helium is definitely used as fuel, no doubt about it. We use helium during test launches exclusively for safety reasons, because the equipment is new and the people involved are engineers who are working things out, not professional operators, for added safety. So, it definitely makes sense to use helium to reduce significantly the risks of any emergency situations.
In the future, it's hydrogen for the stratosphere. Hello? The technologies that will be used in the design and assembly of the airships themselves exist, of course. What about patent protection? Is there any kind of protection or any sort of safeguard for our airships on that particular front? We are currently developing a strategy within the project specifically for patent law within our country, as well as in the European, American, and Asian zones. The zones are divided. But for now, I believe not just for now, but in general, that our team is protected simply by the presence of experience, knowledge, competence, and the very possibility of creating this airship. If someone else out there manages to create something similar and takes a look at what we're doing, I think that would only add to the overall growth of aviation. But there's also a downside to this that we're considering. Some unscrupulous character could potentially and maliciously use this mechanism against the project in a way that could potentially cause significant issues for the project and its stakeholders, meaning they could patent something ahead of time and then terrorize the company with it. From this point of view, it is absolutely necessary to protect and still patent the main components and solutions for which such a scenario can occur in order to ensure. But in general, I like Elon Musk's policy, how he opened all the patents for his Tesla, for his rockets. He says, use it. If someone can repeat it, I will be only glad. But we need to have protection from all angles. We're developing a strategy in this area, and we have a top-notch specialist we're consulting with. So of course, we'll be protecting ourselves.